All right, second example of solving a system of equations with three variables. This is example 1b here. Let's solve our system. X plus y plus 2z equals -7. 3x plus y minus 2z equals 7. And then -x minus 3y plus z equals -9. All right, and before we get started, let's again kind of recap our process from before. So first thing I need to look for, hey, what variable could I eliminate nicely? And then I want to pick a pair of equations, eliminate the variable from that pair, pick another pair, eliminate the same variable from that pair. And again, it's helpful to have my equations labeled, equation 1, equation 2, equation 3, to help keep our work organized as we go. Looking at my equations here, I see right away I have a 2z and I have a -2z. So let's eliminate our z's. And you definitely do not need to eliminate the z's. You could think, hey, okay, the x's, I have an x and a -x, let's work with those. You could say, hey, I have a y and a y, I'll work with that. It really doesn't matter what variable you eliminate first. But I chose to eliminate a z right away. So my first pair I'm going to work with, since I have the 2z and the -2z, I'll work with equations 1 and 2, where I had x plus y plus 2z equals -7, and 3x plus y minus 2z equals 7. To get my z's to cancel out, 2z and -2z, we add our equations straight down. So x plus 3x is 4x, y plus y is 2y, 2z plus -2z cancels, and then -7 plus 7 is 0. I got my equation with two variables. Okay, that's good. Let's look at our next pair. Again, I need to eliminate z's. And I'm going to have to use equation 3 somewhere in here. And because I have a positive z, let's use my second equation where I have the -2z. So equations 2 and 3 had 3x plus y minus 2z equals 7, and -x minus 3y plus z equals -9. Well, right now my z's aren't going to eliminate, but if I multiply my second equation by 2, they will. So this equation becomes -2x minus 6y plus 2z equals -18. And then my top equation didn't change. 3x plus y minus 2z equals 7. To get my -2z and positive 2z to cancel, again, I have to add straight down. 3x plus -2x is positive x. Y plus, and that's a -6y, is minus 5y. Z's cancel. 7 plus -18 is -11. So after this, I have my two equations with two variables. They both have an x and a y. Solve them like a regular system. So, 4x plus 2y equals 0, and then x minus 5y equals negative 11. Okay. With these two equations, I have a 4x and an x, so hey, let's eliminate the x and multiply this bottom equation by 4. So this becomes 4x minus 20y equals negative 44. And then my top equation was still 4x plus 2y equals 0. To get my x's to eliminate, I have a 4x and a 4x. I have to subtract straight down. 4x minus 4x cancels. 2y minus negative 20y is a positive 22y. And then 0 minus negative 44 is a positive 44. That works out nicely. We'll divide both sides by 22, and we get y equals 2. I got one variable. Let's plug it in. So I'm going to take that y equals 2 and plug it back in to either of my two equations here where I just had two variables. 4x plus 2y was 2 equals 0. This becomes 4x plus 4. Subtract 4 from both sides and divide by 4, x equals negative 1. And now we take our x and our y, plug these values back in to either one of our originals. I have an x and a y, so let's use the top one where I just have x and y. My equation was x, but I know x is negative 1, plus y, which we know is 2, plus 2z equals negative 7. Negative 1 plus 2 is 1, plus 2z. Subtract 1 from both sides. 2z equals negative 8. And then divide both sides by 2. Z equals negative 4. Once again, we take our solution, our x, our y, and our z, write them as an ordered pair. X comes first, then y, then our z value. And that's our solution, negative 1, 2,